Hey everybody, this is Larry. This is me going over this daily problem, the last day of the month, the last day of the year. If you started with me, 365 straight days of daily problem solving. Hit the like button, hit the subscribe button, join me on Discord. If you watch a lot of these, I want to thank you for your support. I'm still going to be doing these, so don't worry, I'm not going anywhere yet. But yeah, I just want to thank you for your support, and yeah. So this is a long video, so I'm going to do them. So this is, I usually for the long videos, I do them a little bit out of order. A common question that I get is how long do you how much time do you spend before you give up? And my answer is apparently at least this long. I just keep going, and at least for me, I know that I have most of the tools to solve the problem. Certainly for if you're still on your beginning, like if you're beginning your track, there are just a lot of algorithms that you might not know about. So it's okay to give up, whenever you feel like. But that's basically what I want to go over. My video is really long. Feel free to. So I'm going to do the explanation now, but you can watch my missteps. You can watch it, you can skip ahead, you can fast forward. I do a little thank you at the end as well. So today's problem is stamping the sequence. This is a little bit weird for me because I actually it is greedy. I recognize this as greedy. I was trying to come up with greedy algorithms, but it turns out that and there, I was trying to do topological sort and stuff like that, but it turns out that you can actually just think about it backwards. And it took me a long time to get it. Some of it was, if you watch the video, a lot of it was just implementation, because I think I could have gotten the implementation much quicker and then get the wrong answer much quicker and then move on to another attempt. But sometimes, you can have one of these days, you're going to have good days, you're going to have bad days. And today was a little bit of a rough day, especially since I went, I exercised a lot, I ran a lot, and I was hoping to sleep early. And instead, it is 4:50 a.m. and I'm explaining this problem. So mistakes were made there, but that's okay. But for this one, it is, I don't know how to describe it. It is greedy in a way, but basically, you just take any move that you. Okay, so the thing is that you want to look at it backwards. That's the key observation about this problem. And with that, you just keep on in a greedy kind of way. You take any action or any stamp that could be the last stamp. And if you keep on looping that should be good enough for you to get the answer. And that may sound a little bit hand wavy and sketchy, but that's okay. Don't worry. We'll go over the problem next. I am live explaining this, meaning that I didn't explain it and then, go over it. So we're going to go over my code. We're going to, look at other solutions to see, if there are better solutions and so forth. But this took me a long time, as you kind of see from the YouTube video length. But for this one, so I basically, the way that I structure it is, okay, let's just say, and there's a good case that, let's use this case because that's the case that I have an issue with. So I'm going to explain my thought process a little bit, though you can also watch me go do it over the next hour and a half or whatever. But the idea is that my first idea was just to do it greedy. So here, but like in a different way. So here I did the CBS or ZBS, and then I, here as well, and then XPS and then XPS and so forth, right? But then now we have to sort it in a different way, and I didn't know how to do it. And this is actually an algorithm that comes up here and there, and I used to be actually pretty good at this greedy algorithm proof, but I think I just haven't seen it in a while, and I was very rusty with this problem type. It's not a full type, but there's a sort of greedy that is basically, as long as you could do something, you do it, and then you keep on doing it until you can no longer do anything, because you always make the optimal move, and you always make progression toward the solution. And once you make no progression, then you're done, because any move you make is a progression. So that's I know that that's a little bit hand wavy, but that's the greedy algorithm there. And for this one, for example, the first move or the last move that we can make, because we're looking at backwards, maybe this CBS, you know. So then we stamp here, and because we stamp this last, that means that if you go backward one step, it doesn't matter what you stamp before that, right? Because it's going to get overwritten anyway. So that means that, you know, we can use suffixes in a way. So then after this, for example, we can use ZBS. And then here, you can say that these two things match because, you know, the star will match anything, because if you're stamping, you know, you're looking at backwards, whatever these things match, because later these Z and B will get overwritten by whatever we do later anyway. So then here we stamp this, and then at the very last place we stamp the B. So that's basically the idea behind this algorithm. There are other greedy algorithms that this particular input breaks, and that's why I am using this. For example, if you just want to go here going from left to right or right to left, well, the problem is that you need the ZBS before, you know, or yeah, going backwards or going forward, you need this like this, right, in this order, give or take. I mean, you could do this afterwards, but you know that you have to do this here. And therefore, if you start with a substring like ZBS or this CBS, you cannot converge because, you know, they're mutually doing it that way. So yeah, so that's basically the idea, and this is basically the test case that will break other greedy algorithms. And we'll go over my code, which is kind of short, you know, in retrospect, after you have the right algorithm. So this is a match. This match, let's go over it. It's going to take O of M times, where M is the length of the stamp. And basically it just goes over a loop. It compares these characters, and also this line may be a little bit weird, but basically if the target here is all stars, then we also want to say that it doesn't match because it doesn't change the result because it is all stars, right? Because if this is all stars, then you don't want to stamp there anyway. So that's basically why I count the number of not stars so that we can, you know, check that. And then here is the loop. Yeah, and yeah, so this is going to be O of N-ish. This, as we said, is going to be O of M-ish. And yeah, but there's another loop here, but they're dependent on each other, so that doesn't add the complexity. So this is all O of M, right? Yeah. Yeah. And then, you know, and then this is going to be O of N. And, well, this is just O of 1, so I'm not going to try. And then the question is, well, how is this fast enough if N times M is 1,000, right? The key thing to note is that and you could do a few optimizations here. But the key thing to, we didn't actually even use this. We end up using the target. But the key thing to note is that whenever this matches, it is going to erase M characters at least, or if it matches at the end, I think. Is that true? Well, it's going to at least erase one character, right? So that means that in a very rough hand wavy way, this is going to be O of N because we do one character removal at a time. But it's going to be, you know, fast enough. Dum dum dum. Actually, this is a little bit Yeah, actually, now I think about it, I don't know how it got accepted, because this is actually going to be O, because n characters will get moved, so this is going to be O of n squared times m. But so maybe the test cases are a little bit good, but I would say, this is a string out matching algorithm, so you can actually reduce this to O of n plus m using a linear string matching algorithm, but I didn't do it here. But yeah, so you can definitely do that, and that would make it O of n plus m, and then this would make it O of n times m, or n times n minus n plus m or something, right? So you can do this optimization, though I didn't do it and it still got AC. So, but yeah. Yeah, basically it just tries to find a match, and when it finds a match, it converts them to stars, and then we put at the end. And then at the very end, because we reverse the thing to get the answer, because we're doing the moves from the back to the front. That's basically my code, my solution, my explanation. Let me know what you think. I'm very tired, sorry for maybe this is insufficient, but let me know. Let's go over the solution and maybe to discuss to kind of see if there's a better solution, because I definitely feel like I'm a little bit hand wavy here. Yeah, let me know how you did. You probably did it better than I did, because I mean, you probably did not take 2 hours to do this problem, but okay, it's loading really slowly. Okay, so you keep track of every window. Oh, they did it the other way. Oh, yeah. So actually, I was thinking about it this way. If you, and this is not a thing, but because if you talk, this is actually good too. Though I'm not sure that this algorithm isn't much slower or much faster. But I was talking about, if you watch what I talked about in the because if you watch the video, and it is a long video, I talk about topological sort, and this is basically doing topological sort with a queue-based topological sort. So I think, so that will work because, we talked about this being a topological sort. This takes n times m, and then and then to queue this, I don't know. Oh, I guess they cached this maybe? Because this feels a little bit slow still. Yeah, I don't know. This is just a hard problem. Let me know what you think. And oh, actually, it seems like I did it in 2020, a year ago. And my Python solution's a little bit slow. Let's see what Larry from a year ago did. Why did I do it in C++? Seems like I did it the same way. Yeah, it seems like I did it the same way. So this is n squared times m. Actually surprised that this is fast enough now that I think about it, but maybe there's a way I could prove this to be a little bit lower, but I don't. I mean, I think you can. I think the reason why is that you can say that this will. This will have a behavior that's not. I mean, it's still m times n, but it could be like really, like it's very hard to reach it because there's a lot of early termination. Because once this is not matching, then it's going to be false. And then when you shift everything off by 1, it's also not going to match at a usually earlier stage if it's not matching or something like that, right? Because you can prove that the match will break in an earlier location. until it gets past that point. And because you could prove that with part of the KMP, like how they do the failure function. And again, you can actually use KMP here to speed this up. So yeah, you can use KMP here to speed it up, actually. So yeah, so I'm just going to go by that recommendation. Okay, that's all I have for explanation. Even the explanation was really long because I apparently I'm going to struggled with this one a little bit. Let me know what you think. Thanks for watching me throughout the year. 365-day streak, yay. Yeah, let me know what you think, and you could watch me solve it live during the long thing next. Hey everybody, this is Larry. This is the last day of March and also the last day of the year if you started the Leetcode Daily Challenge the first time it started in April of last year. So that's kind of crazy, isn't it? Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's problem, stamping the sequence. Okay, so for this problem, man, 365 days. All right, 365. Okay, anyway. Okay, so you want to form a target string of lowercase letters. At the beginning, you have some question marks. You are also giving a stamp of lowercase letter. For each turn, you're able to put stamp over the sequence. And then replace every letter in the sequence with the corresponding letter. You can make up to 10 turns. 10 times, for example, and your stamp is ABC, you make ABC. Okay. The sequence is possible to stamp. Okay. So basically you stamp and then you want to overwrite them and you want to do at least or at most 10 times 10 times the number of characters. Okay. And there are 1,000, right? Well, I think we don't have to. Well, so one thing to recognize is that you do not need to minimize. So then that means that well, yeah. So you do not have to minimize. So what I mean by that is that you can be really lazy if you want or whatever. As long as you get the job done, right? So one first thing to note, and I'm trying to think whether it makes sense to do it inwards or outwards, meaning you count from the last stamp or you count from the first stamp. I think there is a greedy solution to solve this because you can note that is that true? I was going to say you never need to I was going to say something like you never need to go back and stamp. I'm thinking about whether that's true. I'm trying to think about counter cases for a greedy example, and my greedy example was just to chop off, the end and chop off the beginning, as many characters as possible at a time. And then my question for that greedy, and you could also, looking at backwards and start with ABCA, and then expand it out, backwards, adding an A and adding a C and an A. Either one is probably similar. But then my question is whether, is there a case in which you stamp once? Let's say we stamp here. You stamp here, and then you stamp the middle again. I don't think so. Because in that case, you would just stamp here. I mean, this is not the example, but you would stamp there. Well, you stamp here first, no matter what. Then you stamp here. Well, if you need the prefix, then you would stamp the left first, so then you go that way, and then so I think this should be right. But as I'm not gonna lie, with greedy solutions, it does take a lot of or maybe not a lot, but sometimes it does take intuition, and sometimes that intuition is just from a lot of practice from in the past, where you just have you work and you do proofs, and then you kind of sense a direction from observations that you made in the past or proof in the past that you can build on top of. Right now, I am trying really hard in my mind to think about that counter case. Otherwise, I might just do greedy. And greedy, you can do in n squared time probably pretty easily, given that this is n squared. But yeah. I think the only thing that's a little bit tricky is, I mean, there are going to be edge cases, I think. For example, if you have even just an example case, let's say your strings are something like, this times 2. Well, then, then you have to be really careful that, you're able to still get CA at some point, or you have to get CA at some point, because one way to solve it is just the same way as you solve 2, but you have to make sure that you don't stamp overlapping 2 of them, right? And then the question is, well, in this case, actually, you cannot do greedy from the back, because if you do greedy from the back, or at least not, you have to be really clever about it, because if you just do a naive thing in the back, this is maybe your first stamp, this may be your second stamp, but then you still have to you have to do A and A. So you actually want this to be last, right? So you have to be really careful about it. And also in this case, you may argue that, or actually I was even wrong, because in here, this actually belongs to here. In some order. It doesn't have to be, actually maybe I miss, no, this is right. Yeah, something like that, right? This is a hard question, both in proving and implementation, assuming that it is right. And we cannot go out of bounds or anything, right? Okay. For these problems, I would, and that's what I'm trying to do, is try to find an invariant that holds true, as we kind of like almost like solving subproblems. I think that you can do some, one question that you might have while watching me struggle on this for a little bit is that, why not dynamic programming? I think the naive dynamic programming is going to be n cubed, so that's going to be a little bit too slow. Given that n is 1,000. And that's why I mean, maybe there's a smarter dynamic programming that we can think about, but the naive, divide and conquer in the middle is going to be n cubed. This is indeed a tricky problem. And now for, and of course, these questions always reminds me of suffix trees, but kind of. Because okay, let's simulate a greedy way that we would do it, right? Let's say we chop this off, so then we're able to chop this off. We know that these are not good, so we would have this new answer, right? Here, well, we chop the A off in the same way, say, but then now what do you do, right? Now it matters. Now you cannot just do the left or the right. Well, in this case, you can actually, no, yeah. Here, you cannot just do the left and the right. You have to do a stamp from the middle. This is the hard part that I think we will have to figure out the greedy on, because you have to do either this or on the left side, you have to do ABCA, or, you know, or if you want, you could use this A from the left, but it doesn't really matter. It's the same. The idea is that you have to do something in the middle before you get the right. Well, do you though? I mean, the answer is yes if you want to be maybe optimal, but maybe that's okay. Maybe here I can, you know, just do this, chop these off, and then here I'll be like, oh, ABCA, and then later, you know, just do this again. I know that we duped this up, but we have a lot of leniency, so that's okay. So then now we chop this off, and then here we get an A, and here, you know, we can chop it off again. Can we do this one at a time? Actually, I guess we can do this one at a time, and then we just kind of, maybe. No, because if we do here, then now we have to do this again. And that would just not be great, right? Like to get the AAA. So we definitely want to optimize these away. Because at a certain point, if you have a long enough string, you know, that's going to cost, like, I guess A2's, it could actually be really bad to keep on doing it. Like, we're given only the allowance of 10 times to the target. So in this case, it is more than just one extra stamp. But that was an idea. Okay. I am solving these live. I guess it is a little bit late in the video to mention this. I am solving this live, so feel free to, you know, skip forward or watch it on 2x or whatever. That is tricky. Because basically we cannot avoid getting into the middle. My delete key is a little weird and sticky. But yeah, you cannot avoid going to the whatever. Can we just sort it that way then? Can we go, okay, we do this, and then here, this overlaps, so then we want to put this before. So we do this instead, and same with here. Yeah, I guess I don't know why I didn't consider this. I'm just trying to think through all the edge cases as well. Okay, let's go through our full algorithm, right? So here, let's say we have something like that. Okay, we go, you know, we go as much as we can, BCA. And then here, we go as much as we can again. That's fine, because this should be on, this gets the suffix. And then the next part, we're here, and maybe here, where we kind of just go here. Then we'll go here, we'll go here, and this actually matches a lot more. And then I guess for this case it actually works out, though maybe I'm mismatching a little bit. No, this is all right. But can we always do that? Well, we can only always do that if the prefix is whatever, right? Like if we add an A, then obviously we can't, because now we have to do a sort. We get this, and then we know that this overlaps with these two, so then we have to put this here. Maybe that's the way to do it. You just keep track of what it is overlapping on the right side, and then go before that. But then, okay. But then now what happens if you add another A, right? I'm gonna move if we add another A, then we want something like ABC here, but we know that we cover this thing, which covers this thing. So here, you wouldn't just sort it here, because this covers that. So that means, wait, what? Wait, what am I saying? Well, here, if we put this here, that's bad. Put this here, that's bad because this covers this. So we know that we have to put it at least here. And then now we don't cover anything in the back. This feels like a stacky problem, but I'm having trouble making sure that I have all the edge cases before we program, because once we start programming, the debugging is going to be a mess. But what is the full formulation? That we want to put this. So as we go from right to left, and is there a not possible? It's guaranteed to possible. Okay. Is this possible? Let me just double check real quick. I just say something like that. BAA, is that possible? No, I guess not, right? Has to be BCA because there's no other way to get the B. Is that true? What is there a case where we can get? No, because even if we remove this with an A, that means that this is a C and this is a B in the final stamp, so that has to be in the substring. Okay. Is this good? Yeah, right now I do spend a lot of time thinking whether, this is good. But it seems okay. So we just do it one character at a time. And from the back. And then the front. The front and back situation, the implementation may be weird. That's why I'm trying to maybe figure out. Oh, there is a sequence is not possible. Return an empty string. Okay, well that one's easy though. Maybe not. I don't. Well, I mean that's one condition, but there are other conditions, so maybe we could just check for that at the same time. I guess this is the final boss of the year or the month, maybe. Okay. Am I happy with this? This code is going to be a mess. That's why I worried a little bit about it. Because there's just a lot of edge cases that I worry about. Though maybe it doesn't because stamp is the same length. So we just have to maybe consider it a sort of a tree. Maybe that's just the way I needed to do it in the first place. Instead of using the so funky stack, we just go for each instance of stamp. Maybe we could, for each instant of stamp, we find that thing, and then we slowly expand our left or to the right. And because then maybe that's a easier way to implement it. Yeah, okay. Maybe that is the easier. Maybe I try to make this too complicated and analyze the complexity too quickly. How would that? What is the complexity of that? Well, it's going to be for each starting point. Yeah, it should be squared to find the starting points, and then for each one, it should be just linear expanding outwards. Maybe. Not sure if that's true. I would say during a contest, I probably would have YOLO'd, but right now I'm just trying to think a little bit. Because then I'm just also thinking about the optimization problem of like, okay, this extending out, how many things can it do, and maybe we can do something with like, KMP or something like that to make that go faster. But it's basically, what is the definition of sticking out? Because sticking out calculation could actually be pretty expensive. Because for each one, we try O of target. I guess it could only be at target square. Okay. Maybe. Yeah, I think that's right. Okay. Let's try it. I think I spent a lot of time on this problem, 20 minutes on this problem, just even thinking about it. It's a hard problem. It's a greedy problem. I mean, I tape these live. All the struggles are real. It's not like, I don't know. I'm not running ads to make it stretch the times longer or something like that. But I think that's maybe people have a better intuition. I think the hard part for me for this problem is just proving it, right? Because I think the idea is not hard, but I think like just proving it and going through all the test cases in my head and showing it, that's the hard part for me. And just because being able to explain it is important, especially on an interview. Though maybe not as much as for competitive. But yeah. But do we do the first stems first or the last stem first? I guess it makes sense to do the first stem first. Okay, so then we would probably reverse this later. So answer is equal to let's just do n is equal to length of target for index in range sub n, kind of. Let's call m is equal to length of stamp. Let's just say this is minus m. Maybe I'm off by 1. I'm always off by 1. M of 0. Oh, yeah, no, this is right, I think. So then if target of index plus m, I think, equals stamp. Let's just print it out just to make sure that I'm not running crazy sauce, because I always get off by 1 on this index. I need to, for someone who does relatively okay, I make a lot of silly mistakes on these things. This should actually happen 4 times or 3 times. Oh no, well, this should happen on this one, so there's an off by 1, so 3 times. Yeah. Is this plus 1? Okay, there we go. Let's just quit start. Oops. So then here, okay. And of course this is n square, because but now we want to put this at the back. Well, we'll put it in the front, and then we'll reverse it later, just like Missy Elliott, right? Okay, yeah. And then now we try to expand as much left and the right as possible. So offset left is equal to 1. So our if statement would be if target of left minus offset left start minus offset left plus m is equal to stamp That's not true. How do we compare only the first X characters? Well, it extends out. It extends out. It extends out. Because if it extends more than whatever, it can only extend out m times, or m minus 1 times, or something like that. So that means that we only look at the first m minus offset left character. So offset left. So the offset is the number of characters we look at. That makes sense. Okay. So that means that this is going to be awkward. Maybe +1 though? I don't know. Let's just print this thing out. I think this should happen once or twice actually on the second one, if this is correct. Did I not print? No, oh, I didn't print the earlier one, but this is wrong then. Let's just print this, I don't know. I'm really bad at string indexes in going across different languages in general, because every language is slightly different. And this, I'm using the slice syntax, and I don't know, I have trouble remembering which one is which, so I always have to do it. It slows me down a little bit because if you're a watcher of the stream, you'll notice that in various different ways, like I don't do this all the time, but I have solved contest problems in Leetcode in C, in Python, in C++, and Java during the contest, and C# actually. So, but you'll see me do it once in a while for performance reasons. But yeah, okay. So this is off by 1. That's good. Oops. I mean, it's good that we know what the situation is, and then there you go. And then now we can go. We can go. Start. Offset left. And of course now we want to put this in a while loop, but let's print out the answer. So what I would expect is just ABCA. So like something like 2 1 something something. Huh? Okay, so maybe not. I thought this would. Oh, I updated the print loop, but not the if statement. That's silly. Okay. Okay, yeah, 2198, because twice for those things. And then now we can just add a loop, which is for offset in range from 1 to m, because we don't want to do m inclusive. So yeah. So in this thing, in theory, we'll get all of the prefix. And I was wrong. Do we not want? This should happen one more time. M is 4. M is 4. 4. No, I'm doing this in a little bit weird way. Because that's not what happens. Because what I'm doing is that, okay, as soon as we match, we actually want to break. I mean, we want to keep going, but we want to break from the start. So we want something like this, and then expand. Well, let's just say this is left as much as possible. Expand left as little as possible, and then we break. As soon as we find one, then we break. And then we do for current start. How do we want to do this? Current start. Let's see. So let's just say found is equal to false. If found is equal to true, then we keep going. We want this to keep going. So then we now Now let's say we use 2 characters. What does that mean? That means that we do the offset, but we change the offset by offset left. And then now we have to also check a few things. For example, here we should check that this doesn't go whatever. If start minus offset left is greater than 0, is what I mean. Okay. Oh, this is current start. Someone like this? And then if not found, we can break, maybe. Yeah. Let's see if this extends all the way to the left. I think it should, but maybe I'm wrong. But maybe it works too well. Because what I want is 2, 1, and then 0. It worked for the first case though, so that's good. I mean, like I said, we have to reverse it, so it's not gonna be right. But what am I doing wrong? Okay, with its break, then we minus the offset. Now, how come we to do this again? That's silly because I append the wrong answer. Okay. Is the target part still right? What is going on there? And this is just really weird. At least it's something that's right. It doesn't even skip any letters, because this is the thing. So it goes here, and then it expands. A very tricky problem. I mean, this index seems. Oh no, this index is obviously we. That's what happens when you refactor without a proper refactoring tool. You rename things and things are just all weird to place. And also, do I have an extra? Oh, it's very hard to read what is going on here because I don't have a big enough screen or something. Okay. So this is what we expect, I think. So it goes here. It goes to the left. Here it goes to the right. Okay. So what I'm thinking now is the obvious thing is just extending to the right, and we have an answer. But while we're not striving to the right answer, the problem is that we have to have a way of keeping track so that we don't stamp things twice. Yeah, so maybe we just have to keep a boolean, a done away or something. And in this case, we want to set done well here we want to set for I in range from start plus m, done sub I is equal to true, and then here we just need to extend the further output. So for I in range from current start to current, well no, it's current start minus offset left, and then current start done sub I is equal to true. So then we can do, if this is not done, this. Because if this is done, then we just ignore it. More specifically, we actually want to break early. This is a tricky problem for a night I wanted to sleep early, but I say that every night, so. Okay. As you can see, this is a mess, and that's what I feared. 987, that's fine. Let's see if, and then this is just to the left, and then now we have to write a similar code for the right. So, yeah, let's do current start. I mean, this part will be easier because it's a little bit copy and pasty, and there's probably a way to dry yourself on this one as well. But for now, I'm gonna write it out because I think you can just change the offset in the signs and stuff like that, and like make it times delta or something. But I think prematurely doing that optimization is probably a little bit cray. Yeah, n or oops, this is greater than or you got n or done occurrence start plus. Though this shouldn't happen. It could happen going to the left because a previous word can do it, but I think this shouldn't happen, but why not keep it, I guess. I'm also thinking a little bit of whether we do this later if this is done. I think we still do, just in case, because otherwise you may crop off a prefix and then you don't start the string, then you would never finish. So yeah, again, there's a lot of intricate situations, which is why, you know, but then that gets cray, right? Because if you have something even like this, then it's going to be really bad for you because you're going to keep on extending, but then on the next thing you're going to start again from here, and that's just not acceptable. I think we can do that if all the characters are used, then we could skip it. Okay, let's play around with that. Again, this is, as I said, there are a lot of edge cases to consider, at least the way that I implemented it, which is why I spent a long time trying to avoid this solution. But yeah. Is this right? I think I messed this up because I was copy pasting. This should be on the other side. And this is why, as I say, yeah, this is tricky. I think I need this to be the next character, so this is off by. Wait, what am I doing? No, this is right. No, this is not. What character am I looking at? I'm looking at the current start plus offset right. Current start plus m minus offset right. And then this is just current start plus m. Right? Maybe -1, but yeah, we might have to do more print statements to confirm this. So that our loop actually terminates. I suspect we are actually going to get our bounce error. I think we should be -1. I was wrong. And unfortunately, we don't print anything, so this is not great. But we certainly... Oh no, this is for this one. I was like, why are we printing so much? How do we not even get here though? Dong dong dong. Probably because of this part. This is the last character, so this is wrong. This is why this is plus something. For every one offset to the right. So why is this weird? Because this should be plus. Is that right? I think maybe that's right. Maybe that's. I really have to get through, but I'm rushing a little bit because this is already running 40 minutes. And still it's not even printing anything, let alone, you know, it should at least print some stuff with respect to here. That's a little bit unfortunate. But that means that these loops are terminating early, which is the problem. Whoops. Okay, there we go. We're getting the wrong length, but at least we're good. So if this is 1, now this is negative of that. Okay, so that's better. It gives us what the... Oh no, this is right. So yeah, 1, 2, 3, and then yeah. So this is good. The left side not so good. Okay, so this is the entire string. We want the last so this is the entire string. We want this maybe. No, this is the first of that string, right? So we want this. Oh man, this is tough. So I think this is right. Maybe not. Because this is the full string. This is to the end of the string, which actually I guess we don't really even need to. Oh wait, we do because target is whatever. Okay, let's see. Okay, fine. There we go. It is very hard to get all the indexes right at 3:44 a.m. But okay. Oh, I actually had this to begin with. What was I thinking? Oh, I guess I just had this side. I was wrong. That is a... I didn't even notice. So I had it right the first time. I am a silly man. Okay. So then here we will do found is equal to true because we'll be found and we keep going. We want append our current start. Yeah, I think we just appended the current start because that's the left side, right? And then we also want to do for I in range of current start plus m minus offset right to current start plus m. I think that's right. Done of I is equal to true. And then okay, and then we're good. We want to move this by the offset right. And then that's it. At the very end, this should be the answer, hopefully. I mean, I have to reverse it, as we say. Oh no. This isn't even right for this one. I mean, I think this is right. It's just I'm putting the wrong thing, which is, what am I doing wrong? Is this plus m minus offset, right? Yeah, I guess so. I don't know. Because that's the beginning of the string, as we know. No, that's not true. That's the beginning of... I don't know what to make of this, but this is clearly wrong because 12 is too long. There's a bunch of stuff here, and also we definitely reuse stuff. But that may just be because this index is wrong. This is the start of the suffix. So what is this? Is this plus 1 maybe? That's the beginning of the actual length of the string that you stamp from. Or not, maybe. So this is the beginning, and you want to minus... Oh, this is this plus m. No, what? So this is the thing that to the end. So the beginning would be... I thought it would just be current start, wouldn't it? Why is it not current start? Why am I getting... Oh, just going to the right, it'll be just 2. Don't we update this to the right? This cannot be 0, so that doesn't make sense. I thought this would be the easier part because we already got the left, but it turns out that there's still some nuance here. What does this mean? Is it possible? Why is it to the right so many times? Do we not break? Oh, I forget to break. That's why. I thought I break. Yeah, whoops. Okay, so now it is way less often. Okay. I mean, this is still wrong, but at least I don't get all these ridiculous numbers, which I was really confused about. Okay. Now what? Now, this should be offset by offset right? Yeah. Sorry, friends. We'll see if we could do any better. And again, we don't have any wrong answer ones, so this is probably not going to be right. The expected answers don't really matter as long as this gets the answer. So yeah, so return answer, this is the reverse of it, but then the question is this the right answer? And then we can kind of simulate this to see if we're the right answer maybe. So yeah. Maybe we'll just do that because I am too lazy to check it anyway, or check to see if this is the right answer, because they just have two answers there. They don't tell you whether they're right, because this may be a right answer, but it might not be be a good answer or whatever, right? Because do we need to step at 6? Maybe not. I don't know. So we definitely have some duplicates for some reason. Why do we have 15 multiple times? Oh yeah, because of this thing. Oh yeah, we didn't implement the thing that we were talking about, so that's why it's gonna have this weirdness, which is if or done sub I for I in range of start plus m. So if these are all done, we just continue because we're already done, so then we don't have to stamp it. Maybe this is just to make sure that we don't run into weird cases. Yeah, so this looks good here. Again, this I don't know if it makes sense, but because we don't really have a check for whether we don't have a check for whether we check the right answer anyway, so maybe we could just do that. Maybe a little bit slow, but should be okay. And we'll go over the complexity if it's correct afterwards. Maybe it's too slow. It should be n squared though, because each character can only be stamped once, I think. Yeah, I think that's why it should be n squared, but okay. Well, it could be newly stamped only once, so that's why it's n squared. But let's I don't know, let's write the reverse of this. Man, this is a mess. But yeah, let's just do constructed string, say is equal to an empty array, an empty array, and then for so let's just reverse answer. For direction in answer, so for index in answer, and let's just set this to empty string times n, right? Yeah, times n, and then for index we can just stamp it, let's stamp it for k in range sub m, constructed of index plus k is equal to stamp of k, right? And then now if let's join it back together, constructed is equal to target, I think it's called, then return answer, otherwise we return an empty array. Let's see. Oh no, we don't return an empty array. Oh, we do return an empty array here, but of course that we can add an impossible case just to make sure that we get at least that answer correctly. I mean, I don't think there's any way our answers will be correct, but yeah. Okay, the judging is a little bit slow, but that's okay here. But what do we return here then? Dun dun dun. It might be that after all this time, my solution is wrong, and that's why I hate greedy things. But yeah, so this is what we printed, but this is the word that we're looking for. We're missing a CA. Because, so why is that? Because when we extend it, no, there should be, that's weird. This should have an offset right of 2. Let's print that out again. Now it has an I mean, it extend this, what? Wait, what? It extend this one. Huh. Let's see. A lot of index manipulation as well, so that's a little tricky. Okay, so this is A, this is, I mean, no, this part is the one that we're looking at. So the, is that right? Because ABCA, So then the next character should be a C, but instead it thinks it's an A. Dun dun dun. That's not right. So we are off by 1 here. That's what I was worried about. Also, we can see that current, we don't, this is wrong. Maybe +1, but so it should extend to 2, but that's a little bit awkward. And also that means that this is wrong. Oops. There's a lot of wrong things here, actually. So it doesn't even match that now. That's unfortunate. Friends, this is tiring. Okay, so C is no good, and then AC. Oh. I'm doing the extension math wrong, I think. No, we get to C, and that's good that it is wrong. So then now we try to go, and now we look at CA. That's how you extend to by 2, but my math is wrong. Yeah, this one, it has to, that doesn't make sense. I think this is why I struggled a lot with, because this should be offset by, you know, because this should be, as we get bigger, this should be offset, you know, like it should get bigger, and this also should be as a result of offset right as well. So maybe not the one is not the issue. It is that, okay, maybe it's this. Am I just that bad? This actually makes sense, but I don't know why I'm so bad at it today. Because this is your start and your offset right is, I mean, I've been working on this problem for an hour, so maybe I am losing steam and energy. Okay. Of course. So yeah, so this is the beginning. But of course, because we always choose M here, that doesn't make sense. So we actually want, so we want the offset from here, but now we only want the last offset. Is that right? That doesn't make sense, doesn't seem like. Okay. So this would be the length of the entire string, but we want to, oh yeah, that's, okay, I am really out of it. This is the length of the string offset, but, well, this is the beginning of the string, and this is definitely the end of the, is this definitely the end? No. What we had before was definitely the end, maybe off by 1, but still. But the beginning would be this thing minus M. No. Minus offset. Is this really the man, my math is really bad today. Well, I don't even know what this index is anymore. How do you even get AB? Sorry, friends. Clearly struggling. Okay. I think what I needed to do was write it out. Okay, but so this is the, is this even right? I don't. Okay, let's think about it again. Okay, I am dumb. Let's just write it out. I'm trying to do too many things in my head. So the end of the string after the offset is going to be this. Okay, end of string. Yes, no doubt. Yes, so actually we don't even need to put it because we just want the end of the string. Right? Did we choose to be? Oh, no. We do need to do it because the end of the offset is this, right? So, okay. So this is the end of the string. Okay. Is this right now then? Did I mess that up? This is off by a bit. Okay, so this is the end of the string. I think we're right here. Except for maybe off by 1. No, this is right. No, is it? Let's see. So the next one is C, AC. Yeah, no, this is right. But we have 2 extra characters for some reason. And then 6 extra characters. What is going on? Okay. So then we want this, but the last offset right character. So it's just... Can it be? Okay. Wow. I'm just really off today. And obviously this length will be offset right because it's just this minus. Okay, fine. Okay, now it gives us the right answer, though maybe we did the same thing twice for some reason. Why do we do that? Huh? Do I not break correctly? Do the offset right make sense? I do want to fix this because... But I mean, it is at least a better answer. It's going to be correct, maybe, unless there's a worst case. But why is this wrong? Okay, so now to the right, 4, 5, 6. Wait, what is that printing again? Current start. Huh? So assume this part is right. Okay, so we do these, but then why does this start again? Did I do something silly? Let's print start. Like why does that oh, this is from the 2 and the... Wait, what? How did it get all the way over there? So it goes ABCA, it adds CA, and then it adds to A, and then it adds to... Okay, so it adds BCA. Wait, what? So it adds... So this adds the CA, and then the A, and then the A. Oh, I see. BCA, and then CA. Wow, that is actually amazing. I didn't know that could be done. But then now this should means that this is all done. Did I? Oh, I didn't do the for loop right. Oh, I didn't fix the for loop. Okay. That's doable. Okay. Okay. So I do have a shorter answer. But that's fine. I'm just gonna give a submit. I might run out of time, but it is 4 a.m. and I'm a little tired. Well, a lot tired. Oh no. Oh, this happens. Yeah. Oh, because offset is 1, so this never executes. I guess technically I should do this. I'm abusing scope a little bit. In theory, you should. Oh, what did I click on? You should have. Oops. What did I do? In theory, you should have another variable that does it the scope, but okay, fine. Why is my Chrome always like? Maybe it's Emac. Maybe it's Leetcode. Come on, please. Oh no. Really? I don't do this? Oh. Feels like I would. That's a little bit sad. Is my to the left wrong? Clearly my to the left is wrong then. Let's see. Well, let's print what it was giving anyway. I guess it doesn't. Did it print anything? No, it doesn't even print anything. It just prints an empty. Oh no, it prints. Standard out is to. Oh. Oh no. Oh. That means it doesn't go to the right enough. Okay, so actually that's not a to the left issue. I actually missed the standard output that I left in by accident. Actually, forgot to remove it from production code. I just got a little confused. But that means that this is off by 1. I think. Oh yeah, I think this is the case now again. So let's try it again real quick. Offset. Oh. Where did I put offset? Oh, did I just... What they say, life never goes according to plan. Okay. Then why is this, you know... Why would it go 0 first? Oh no, that makes sense actually. 1, 2, but then it doesn't go to the right. To the right, to the right. It doesn't go here. There's no to the right. It's possible that I have an off by 1 somewhere here. Because it where's my print? Oh, here's my print. Because basically it is saying that the 0 is our start. But somehow this thing is breaking off. Do I have an off by 1? So this is the beginning. Oh, this is the end. Maybe this. Is that right? That might be right because this is an exclusive. Yeah, okay. A lot of silly mistakes. Now that I think about it, you know, you see me doing this for 70 minutes. I'm ready to just, you know, go sleep and pass out. So that's my excuse, and I'm sticking to it. All right, let me make sure that I don't print anything funky. I've been printing a lot of stuff. Okay, and it returns an answer, so we know that this is true because we reconstruct the answer. It's just that this may be a little bit slow. Oh no. This is the problem that never ends. This feels like my algorithm would work. So, oh wait, would it? Huh, actually maybe I'm wrong on this one. Because it claims that, you know, I mean, we can remove a lot of the silliness. Let's run this real quick. Yeah, my code doesn't do it, but it should. So ZBS and the suffix. Oh, that's bad for my algorithm, because basically you want the B to be you want to do this index first, or well, you want to do this index first to get the B, and then everything to the left. And I was looking for this case for so long, and I couldn't figure it out. And now what? And that's the problem with greedy, is that, you know, now what? Dun dun dun. Because this basically means my code is fundamentally wrong. Wow, this is the longest I've spent on a Leetcode problem in a long time. Should have done it in the morning instead. But basically, just to explain this a little bit in case that wasn't clear, you have something like this. So the optimal move is actually ZBS and then ZBS, and I mean, in this case, I don't even think the S matters. It could be this, but the idea is that this, right? And I was looking for this case, but clearly missed it. And then the question is, how do you resolve this? Because you cannot, here it does not extend here in a good way. Or at least not, I mean, can we modify the way that we did it? I mean, I think yes, but it is just a lot more cases, so that's annoying. Maybe I'm just being dumb, to be honest. Now I feel like one of my initial hunches should have been right, which is just pick one letter at a time for each one, and then not worry about optimizing. And what I mean by that is, you know, you have a B, just match it up so that the B matches there, and then next you have a Z, pick the Z so that matches it, and then at the very end, you know, you can figure it out. I think that's the slightly better, and let me try to do it on the earlier case that I had, which was something like this but times 2. So then here, the idea is that, okay, now you have this, and then go left, just one at a time, and it doesn't even matter whether it matches or not. You just go one letter at a time, go A, and then that's good. And then go right, you can just do, you know, C. You can, it doesn't even matter, right? You do A, B, oops, C, A, and then next you just do the A anyway. So let's just do A, B, C, A, and then you keep on going to the end. So you just find the first instance, and then you just keep on going. I was thinking about along those lines, but I think I just got a little. I try to optimize too much, and then here, and then you do this like 3 times. I mean, you can maybe do adjacent minuses, but that's, you know, like you could dedupe adjacent ones, but I guess that's it. Okay. I'm just being really silly today, I guess. Yeah, okay. So this greedy I think would work. And can't believe I spent an hour on this and still not right. Greedy problems are hard. Okay. So basically we find the first instance, and then we just go left and right. Okay, so let's say we have this. Do I want to keep all this? And it took so long to get these things right. We don't have to worry about this, maybe. But okay. Okay, I think I got this. Is the also this is much easier to code. So yeah. So if stem not in target, we return empty thing. Otherwise, we just keep on trying one character at a time. Yeah. Yeah, I mean, okay. I think I got it, except for it's a little bit messy still. But otherwise, start is equal to target index of stamp. I think this works, right? Let me just print it out because I'm very wow, this is the long and that's the problem, is that as you kind of get tired, it gets more tiring. Okay, and then now you go to the left, which is the same way. So you want to take the leftmost character of each of these characters and then take it. So let's just have a lookup table, so of the stamp. So first lookup table, say, and you have yeah. So then for index C in stamp, or enumerate stamp. But sometimes, you know, I would say, yeah, I mean, I'm a little bit unhappy about it, but the error and the discovery is what will make you be faster next time for similar problems. Whether you believe it or not, that's up to you. But, you know, I don't, you know, if you may, why did I do this twice? You may ask, you know, a common question that you may ask is how long do you spend on the problem? And I don't know how, if you're actually, you know, still listening to this, because this is like 70 minutes in, but how long do you spend a problem, right? Well, now you know directly how long I you know, before I give up. I mean, that said, for certain problems, you know, you just need to know certain algorithms. But for this one, it's going to be, I don't know, I guess I knew it was going to be greedy in some way. I just have to find the right one. Yeah. Okay, so going left. And I had a lot of off by ones anyway, so that wasn't even, you know, even if I had gotten it right, it was silly. So going left, we use the first character as the matching. So yeah, also we want to stamp the start, and then of course we reverse this later. But yeah, going left. 4 offset left, let's call it that again, why not? In range from start -1 to 0. It's very awkward, but yeah. Yeah, okay. No, this is an offset start actually. Yeah. So we get that letter, yeah, so target sub offset start, let's print it, because my mind is not able to hold too many variables in my head anymore. It's 420, not intended per se, but you know, congrats to the 420 family. But yeah, 4:20 a.m. though is not great. I did a lot of gym exercise today, so I was hoping to get enough sleep. But well, this is the big boss, the greedy algorithm. Yeah. Anyway. Okay, what am I doing? Oh yeah. So then now we want to see the first instance of that character because we want to greedily choose this character at the beginning. So yeah. So the stamp offset is equal to this. If offset start is or minus stamp offset is less than 0, we just that's not possible. Otherwise, we stamp offset start minus stamp offset. Yeah, I think this is. I don't know. I've been saying I think this is right a lot. So let me just take a look, and let me just. Okay. Oh, it doesn't even try to. Do I have a print? Oh no, I removed this print. That's why. I was like, tell me what word I get, please. Okay, so this is good. Again, we have dupes, but that's fine because it still works. We obviously this wasn't going to be to solve everyone because we didn't go right. And then now going right for offset start in range from start plus 1. I think it goes to start plus m. Or sorry, it goes to n minus m. Maybe. So yeah, we take the last one. Again, this is a lot of index counting. So we use the last character. If this is the last character, what does that mean? This was giving me so much trouble last time. So offset start, it's where you're going to stamp. So we always stamp the offset start. The start length is going to be m. And then, okay. So offset start plus m is the end of the string. And then we want to, wait, is this true? No, I don't know if this is true actually. Okay, Larry, come on, get it together. Okay. So offset start plus, I'm really tired, sorry. Okay, so offset start plus m stamp offset. What does stamp offset means? So if the stamp offset is 0, that means that we want to stamp at we want the offset to actually be well, the stamp offset cannot be 0. Oh, I guess it could be, but that's just really awkward. Can it be 1? Yeah, I mean, I guess it could be actually, or 0. But yeah, then in that case, if stamp offset is 0, then we want to stamp on offset start plus m. If stamp offset is 1, we adjust the stamp to 1 to the left. So then this is this minus stamp offset. Hopefully this is roughly right. Oh no. Huh? Why is this wrong? Oh, because this is probably off too much. So this is the length of this because this is going to go out of bounds. Oh, well, okay, I see. So if the stamp offset is 0, that means there's 0 overlap. If there's 1, that means there's 1 overlap. So this is this plus another m. Is that right? Well, let's do some ASCII art. Okay, so let's just say we have ABCA, ABCA, and then now we did ABCA, and then now we have looked for an A. Okay, maybe we do ABC. Oh no, this is A, but we have ABC. Now we have to find an A. So then the A would be here. And the offset, so the offset start would start. Wait, I think my offset start is wrong. That's why. So my offset start is not start plus 1 because that's not the one that we're looking at on the target. Our offset start is should be this character. So offset start should be start plus m. And then now we start at the character that we're looking at, which is here. And then we look at the last character, and then we maybe subtract that from that. Okay. Because for every one offset, we go back from the start. Right? Maybe still be off by 1, but maybe it's closer. Nope. Okay. I mean, not the right answer, but have some answer. I mean, we returned something, but I think our index is bad. We also like didn't stamp some letters in the back, so I think we because now maybe something like that. I don't know. That makes sense actually. Yeah. Actually, no. Now it makes sense. Because before I was counting it the other way. Maybe not. Actually. Well, no. This should be at. Go all the way to the end. I'm happy with this. Maybe. My implementation is really bad. My health is deteriorating. Please send love and whatever. And I don't even. So it's looking for CA. Is that right? What problem is this? I have too many test cases. This problem. Okay, so looking for here. So for this one, we're looking for a C. ABCA, we're looking for a C. That's fine. So we find that to be in offset of 6. Is that right? Oh no, that's the offset start. Okay, and then that means that start step offset. Okay, so we find this in 0. So that means that we stamp at 6. Right? That makes sense, right? And in this case, yeah. So why is this wrong eventually? Oops. 13, so CAC. So we're missing one letter for some reason. That doesn't make sense, right? Does it? How would that make sense? Yeah, I didn't think so. Oh, but maybe this. So this is the offset. Let's say we stamp here. We're going to get this and then -1. Okay, maybe that's why. Okay, we're still wrong for this one though, unfortunately. Which was what started us off to begin with. Let's see. So we started XPS. We started an S, okay. We started a B, okay. How come we don't do the Z? Yeah, 5, 6, 1. Oh. No, we do this at the end. 5, 5, 5. Yeah. Oh. That really wow, I am really bad at this. Because we said we was gonna go. No. No. Oh. Wait. Is it? Oh, because printing here will overlap with the Z. So our new algorithm is better, but it's still the same as what we did before. I thought about this case. I mean, I wrote this just for this case, but why did I think? Oh, because we look at it one character at a time, but then because this overwrites the rightmost character, we need the rightmost to be first. So we need to sort it that way. How do we sort it that way then? I mean, these answers are funky looking, but they should be right. I mean, I guess we can reduce this to a topological sort. Where for each character, I think I tried too hard to be smart about this. I think we can just wildcard match. Yeah, I think that's the way to go. By working backwards. I don't know. Sorry, friends. My thing is a little bit weird today, but okay. Let me try something that's a little bit YOLO, but I can't really prove this either. So I don't know. Maybe this is just one of those days. Well, true. Okay, let's see if we could find a word. I want to convert this to an array. How do I do this? I think just list it. Okay, and then now we have for well, let's just do old target. So yeah, we still have the target, so then we could do this check later. So yeah, for start in range sub n minus m. Okay. If this match, if match start, yeah, let's just do with match start. Then, yeah, guess we can probably do it this way, right? Let's see, match index, and if we just do a for loop, yeah, for offset is equal to in range sub 0 to m. I guess this is technically the offset, and this is just I. So if stem sub I is equal to target sub I plus offset, or target I plus offset is equal to some character that we already finished, then yeah, then this is good. So if not of this, and this is, so that means if De Morgan's law, we return false, otherwise we return true. And then if these two matches, then we just we found is equal to false, found is equal to true, and then we just kind of well, we set it, yeah, so for I in range of start plus m, target of I is equal to start, and we also put it pen of start. Again, if not found, return an empty array. Time limit exceeded, maybe because I have an infinite loop. Oh yeah, because at the end it's gonna be all stars. It found. Okay, if all stars, then we're good. What am I doing? Looking for target, right? If target sub x, x is equal to star for x in target, we break as well. Oh yeah, okay. I saw this wrong end and I got confused for a second. Oh no, is it still time limit exceeded? Why? Oh, because it could still match a subset of this. So then, yeah. So, okay, so we need at least one character that is in this. So, yeah, okay. So, count is equal to 0. If stamp is not to do, count increment 1. I mean, we can actually just whatever, but return count is equal to 1 or greater than 0. Okay. Time limit exceeded. Okay. Oh, this is still time limit exceeded. What other scenarios is this doing? Okay, let's simplify the thing first. Is it even getting it wrong for the first case? No, okay. I mean, it's not the right answer, but oh, well, because we have to, okay, so this is old target, but still. Output limited exceeded, that's fair. So our output is APAs. Did I mess up again? Well, here it just keeps going, but it doesn't match anything. Oh, this should be, if this is the case. No, I mean, this should be right. Oh, can't implement anything today. This is start plus I. Oh no, that's not true. Oops. At least it'll terminate because, yeah, I messed up. But, how did this happen? How did this happen? Keeps on matching 0, but I thought at 0 this is oh, this is okay. Okay, so that is that it terminates, but why is this wrong? Plus 1 maybe? Maybe I'm just off by 1 again. Okay. Oh no, did I not have all my, oh, luckily, I should put it somewhere, but I had it in my paste. I might be printing too much, but that's fine. Yeah, I mean, at least that matches. So let's give it a submit. So I spent an hour and 45 minutes on this. I am not happy, obviously. It is the last one of the month. I just need more sleep. Yeah. So if you're watching it here, I don't know why, but I appreciate the support. I'm going to do the explanation, but I'm going to record it in the beginning of the video. So, or if you're watching this, you already saw the explanation. So yeah, let's do that. And yeah, so with that, I'm going to say my goodbye. Thanks for, I don't know how long you've been here. I guess I'll say my goodbyes in the beginning, but yeah, I don't know how long you've been here, but thank you for your support. Been doing this every day of the year, so yeah. I'll see you tomorrow, new day, and yeah, Kind of crazy. It's been a year, huh? Yeah. Let me know what you think, and yeah, take care of yourself. Have a good, rest of the month, week, whatever, and to good mental health. I'll see you later. Bye bye.